find out, I guess. All right, so we're going to do 3, 5. 3 and 5 is a continuation of what we did yesterday. So you're going to see a lot of the same things with the P's and Q's and graphing it to find zeros, synthetic division. But now the big difference is we are going to get, oh, my mask is caught. There we go. We are going to get imaginary solutions, complex solutions. All right, we are going to start with a couple problems like what we did yesterday. And we mentioned this theorem. You don't have to write this down. We mentioned this theorem yesterday when we were solving. If you had a degree 4 polynomial, we got 4 solutions. If you have a degree 5 polynomial, you get 5 solutions. That's what this fundamental theorem of algebra says. It says whatever your degree is, you're going to have that many solutions. The reason it shows up now is because now that's going to include possibly imaginaries as well. So let's say you have a degree 5 polynomial, you might have 3 real solutions and 2 imaginary solutions, and then total, that's going to give you the 5 that you're looking for. We're going to start with this problem. Now, we spent a lot of time on Tuesday foiling these out, so we're not going to spend as much time today doing that part because we practiced that already. But we are going to practice setting up when you have an imaginary number as a root, as a solution, and working backwards to write that polynomial. So polynomial of degree 4, leading coefficient of 3, and it has zeros at -2, 1, I, and -I. So I'm going to say P of x equals here. And then my leading coefficient, 3. And then it's a degree 4 polynomial. So we're going to set up 4 parentheses. 1, 2, 3, 4. All right, so a little bit of this is review now. If -2 is a 0, what's the factor? X plus 2. It's the equation that if you set it equal to 0, you would get that as a solution. If 1 is a 0, what is the factor? X minus 1. So what do you think if I is a solution, what's the factor going to be? X minus I, yep. And then if -I is a solution, X plus I is going to be my factor. Now, factored form can never include imaginary numbers. This needs to at least be all real numbers. So what we're going to do is we're going to FOIL together any terms that have our i's in them. So x minus I and x plus I. Everything else I'm just going to bring down. So 3, x plus 2, x minus 1. All right, if I FOIL this out, first terms, x and x give me x squared. My outside's going to be an ix, and my inside's going to be a -ix. So what happens with those? They're just going to cancel. Outside and inside cancel because those are conjugates. My last terms are going to give me, if I multiply those together, a -I squared. Do you guys remember what I squared is equal to? Close. -1. So if it's a -I squared, it's equal to +1. So maybe make a note to self, little asterisk on the side of your paper, I squared equals -1. Anytime we see that, we want to do the replacement because there's a negative in front of it. That's where we're getting a +1. This is your factored form with all real numbers. When you see the instructions in Math XL, it might say write it as a product of linear and irreducible quadratics. Well, the linear terms are the x plus 2 and the x minus 1. And then the irreducible quadratic is that x squared plus 1. I can't factor x squared plus 1 anymore and have real numbers. So that's as far as we can reduce it as far as the factors go. Okay? Then in Math XL, you may have to put it in standard form, which that's just review from what we did on Tuesday. So remember, you're going to pick 2 parentheses, FOIL them together, take another parentheses if you have it, FOIL that in with it, and then last but not least, distribute the 3 through. So everything past that is just review from the last section. Okay? All right. Now, conjugate pairs theorem talks about very similar to what we did with our irrational numbers before. If a plus bi, that complex number in our book uses z to represent our complex numbers, is a 0 of our polynomial, then its conjugate, a minus bi, will also be a 0. So just like the irrational numbers before, when we had like 2 plus rad 5 and 2 minus rad 5 was a 0, same thing's going to happen with imaginary numbers. They're always going to come in pairs. So if 5 plus I is a 0, 5 minus I will also be a 0. And most of the time, they're only going to give you one of them, so you're going to have to know to look for that other one. So we're going to practice this one. And you can see the instructions here. Write it as a product of linear and irreducible quadratic factors. That means we at least need to FOIL to a point where everything's a real number to get our final answer here. All right, so it is degree 6. I know I'm going to set up 6 parentheses. 1, 2, 3, 4, 5, 6. Leading coefficient is -2. -2 out front. I have a 0 of 2 minus 5i. What else is a 0? If 2 minus 5i is a 0, 2 plus 5i. And if -3 plus 2i is a 0, what else is a 0? -3 minus 2i. The only thing that's going to change is the number or the sign between them. And then 2 multiplicity 2 means what? It means it's squared, it occurs twice. So I'm going to put that one in there first, x minus 2, x minus 2. Or you could just write x minus 2 quantity squared if you don't want to write it out twice. All right, and then my other 4 parentheses here are going to have my complex numbers in them. And this is just like what we did with the irrational numbers. When we put our term into the parentheses, we're changing the sign of both pieces of it. So instead of a 2 minus 5i, it's going to be a -2 plus 5i. Both signs change on those terms. Instead of 2 plus 5i, that one went there, it's going to be -2 minus 5i. Instead of -3 plus 2i, it's going to be a +3 minus 2i. And then instead of a -3 minus 2i, +3 plus 2i. Okay? Now we are not putting the whole thing in standard form. We are just foiling to a point where we have irreducible quadratics, which means we're going to FOIL this pair together and this pair together. Now each of them are 3 terms times 3 terms. So how many terms am I going to get when I FOIL? 9 terms. All right, we're going to do the first one together, and then I'm going to let you do the second pair with your groups here in a minute. So I'm going to multiply x times everything in the second parentheses. That's x squared minus 2x minus 5ix. -2 times everything in the second parentheses. -2x, +4, +10i. And then 5i times everything in the second parentheses is a +5ix, a -10i, and a -25i squared. Just like the irrational numbers, if you are doing this right, a bunch of stuff should cancel and you're going to be left with a quadratic. What cancels? Okay, good. -5ix and +5ix cancel. What else? 10i's cancel. And then I can simplify one more thing. I have an I squared. So instead of -25i squared, if I squared is equal to -1, that term can become what? +25. So putting it all together now, I'm just going to bring down that -2. I have an x squared, a -4x, and a +29. That's that irreducible quadratic. And if you solve that quadratic with the quadratic formula, 2 minus 5i and 2 plus 5i will be the solutions. So we're using the solutions to build that quadratic. Okay, with your groups, see if you can FOIL out the other pair that's listed there in the middle. And then those x minus 2's we're just going to bring down at the end, x minus 2 squared. That's going to give us our answer. Did you get x squared plus 6x plus 13? That's the correct answer. All good there? A lot of foiling, but anything with an I should disappear if you're doing it right. If you still have an I after you FOIL, something went wrong, you want to go back and check your work. I do have a shortcut for that foiling, which I can show you. If you don't remember the shortcut correctly, don't use it. Just FOIL out. Okay, that's why I do this first, because a lot of times people will try to use the shortcut and then it doesn't work out so well. Let's say I have this that I need to FOIL. X minus 4 plus 7i and x, I'm just making something up, minus 4 minus 7i. Okay, shortcut. My answer is going to be x squared plus something times x plus a constant. It's going to be a quadratic. All I need to find are those two numbers. Those two numbers, the number in front of the x will be if I add the middle terms together. Negative 4 and negative 4, negative 8. The last term will be if I multiply the middles, multiply the lasts, and add them together. So here, if I multiplied the middle terms, I would have a 16. If I multiplied the last terms together, I would have a negative 49i squared, which would be a positive 49. And if I add those together, I get 65. It also works with the irrational ones we were doing. Like let's say I just change that instead of a plus 7i, if I change it to a rad 7. Same rules are going to apply. So add the middles together, I get negative 8. Multiply the middles, multiply the lasts, add them together. So here that would be 16 positive rad 7 and negative rad 7 is just negative because one's plus, one's minus. Radical times itself is the number underneath. 7, 16 minus 7, 9. Okay? So if you want a shortcut, there it is. That'll save you some time foiling. If you feel like what you're getting is not matching up, not correct, just go back to foiling it out, get all your 9 terms, put them together. It's probably a more accurate method overall, I would say. Okay. Any questions on that? Okay. The next problem on your big idea worksheet, you guys are going to see one like this on Math Excel, so I want to give you a little hint for it. So it says, find an equation in polynomial form of least degree having complex zeros, intercepts, and the following graph. So from this graph, what is the y-intercept? Let's just get that information. Y-intercept is the point where it's crossing the y-axis, right? What is that point? Don't overthink it, guys. It's labeled, right? 4, where it's crossing the y-axis? Yes? Okay. What's an x-intercept on this graph? 3. Okay. We also have solutions, which x-intercepts are part of solutions, at I and 2i. If I and 2i are zeros, what else are zeros? And negative 2i. Okay, so how many factors am I going to have? 5 factors, right? Because I have 3 and then I have 2 pairs of complex numbers. So let's set it up. 1, 2, 3, 4, 5. This one's not too bad. X minus 3, then my i's, x plus I, x minus I, and then x plus 2i and x minus 2i, those pairs. Now, because it's just an I and a 2i, you're just regular foiling, first, outside, inside, last, but because they're conjugates, the outside and inside, we know we're going to cancel. So I've got an x minus 3. If I FOIL the middle pair together, I'm going to have an x squared. I and negative I will give me negative I squared, or positive 1. My last pair, I'm going to have, again, an x squared. Outside and inside cancel. Last terms are a 2i and a negative 2i, which is negative 4i squared, or positive 4. Now, the only thing we haven't used is the y-intercept. And the reason that we use the y-intercept is because you are still missing your leading coefficient. We don't know what a is out front there. So you need another point to figure that out. And that's the y-intercept. We have a point at 0, 4. So we're going to take 0, 4, and we're going to plug it into this equation. My y is 4, and all my x's are 0. 0 minus 3, 0 squared plus 1, 0 squared plus 4. So I'm going to have A times -3 times 1 times 4, which is -12. Multiply all those together. So A is equal to -1/3 when I do 4 over -12. So then you could plug that in for A, and that would be your final answer then. Okay? Make sense? How we use that graph to help us get those pieces of information we're missing. Okay. Questions? Okay. So we're going to jump around a little bit. We're going to do a problem. I think it's on the back of your paper. Starts with 2x to the 5th power. This is just like what we did yesterday. Find all zeros, and actually I'm going to even cross out the word real. We're just going to find all zeros to this polynomial. So how did we do this yesterday? What did we start with? P's and Q's. All right, P's come from my constant term. What is my constant term? 6. Factors of 6 are 1, 2, 3, 6. Q's come from my leading coefficient. My leading coefficient is 2, so my factors are 1 and 2. P's over Q's. Plus and minus 1, 1/2. 2. 2/2 is 1, it's already on my list. 3. 3/2. 6. 6/2 is 3, it's already on my list. All right, I have a starting place. What did we do next? Graph it. All right, get out your calculator. Put in y equals. And remember, we're just looking from this graph. Approximately, are any of these numbers, these P over Q values, x-intercepts on this graph? I won't bring up my big one since you guys have it in front of you. How many times am I going to have to do synthetic division on this, by the way? Remember we talked about that yesterday? The degree tells us how many times we have to do synthetic division. Okay, if it's degree, what's the degree on this polynomial? 5. How many times do I have to do synthetic division? Not 5. Less than that. Less than that. 3. Because what's our goal? To get it to degree 2, right? Quadratic we can solve. So what's the difference between 5 and 2? 3 times each time when I do synthetic division. All right. From your graph, guys, which of these numbers do you want to try? What would you say? Let's just get some estimations here. +1/2. +3. We need at least one more. We got to do synthetic division 3 times. 2? Okay. Let's get our synthetic division start up. 2, -11, 19, -17, 17, and -6. Not missing any terms, don't need any zeros. Which one do you want to try first? Doesn't matter. 1/2. All right. Bring down my 2. Half of 2 is 1. Plus -11 is -10. Half of -10, -5. Add them together, 14. Half of 14, 7. Add them together, -10. Half of -10, -5. Add 12. Half of 12 is 6. I get a 0. Remember, do not go back to the original equation. We're going to keep making this smaller and smaller now. So pick another number off the list. 2. Bring it down. 2. Multiply 4. Add -6. Multiply -12. Add 2. Multiply 4. Add -6. Multiply -12. Add 0. Okay, we got 2 answers. The only other number we haven't tried yet is 3. Bring it down. Multiply, add, multiply, add, multiply, add. All right. I had degree 5. I did synthetic division 3 times, which means now I have degree 2. Put the x's back in. 2x squared plus 2 equals 0. Solve for x to get your remaining 2 solutions. Do I have to use the quadratic formula here? Do not, because it's just an x squared term. There's not an x here. So you can just get that x squared term alone. Subtract 2. Divide by 2. And then we take the square root. Now, up until now, when we take the square root, we say no solution because we have a negative under the square root. But now we will have imaginary solutions. And that's the big difference between this section and the last one. So I'm going to put plus or minus here. What is the square root of negative 1? Positive and minus I. If it was the square root of negative 3, what would your answer be? Plus and minus I rad 3. You guys remember doing that? Algebra 2? Okay, if you have a negative under the square root, it's just an I, and then you reduce the radical as usual. So if I said the square root of negative 4, square root of 4 is 2 with an I. If I said the square root of negative 7, it would be I rad 7, because I can't reduce that 7. Okay, questions there? All right, so the last type of problem we need to do is this guy. Find the one that has the 3 minus I. This problem is a non-graphing calculator problem. Make a note to self. No graphing calculator for this one. The reason you do not have a graphing calculator is because they are giving you a 0. It's not just here's a polynomial, find all the zeros. They're giving you a starting place. So you are able to solve it from that starting number. Okay? If they don't give you anything like the last problem we just gave you, you would have to be given a graphing calculator to be able to solve that. If 3 minus I is a 0, what else is a 0? 3 plus I is also a 0. And if we have zeros, what's the next thing we do with them? We write them as factors, yeah? Let's do that. So 3 minus I will look like what as a factor? X minus 3 plus I. And 3 plus I will look like what as a factor? X minus 3 minus I. Okay? All I can do now is FOIL those together. It's my only option, just working with what I got. All right, let's use the shortcut. Let's see if we can do it. So it's going to be x squared plus a number times x plus a constant. How am I going to get that middle number? Add the middles. Negative 3 and negative 3 gives me negative 6. All right, how do I get the last number? Flip that, what you just said. Multiply the middles, multiply the last, and then add them together. So multiply, multiply, add. So negative 3 times negative 3, 9. What's I times negative I? Negative I squared. I squared is equal to negative 1. So it's plus 1. Put those together, I get 10. Okay? If you don't want to use a shortcut, just FOIL out all 9 terms. The i's disappear. All right, so here's what we know. We know 3 minus I and 3 plus I are zeros. We know that what we wrote in the parentheses there were factors. And if we multiply factors together, we still have a factor. This quadratic that we created is a factor of the original polynomial that we're trying to solve. Now, I want you to think back to what we talked about with division. If we have a factor and we divide it out, what should happen? We get a remainder of 0. And then the quotient that we're going to get, the answer, is the other factor. That's what we need right now. We need that other factor that if we multiply it by this quadratic gives me the polynomial, because that other factor is containing the other 2 solutions I'm missing. So we're going to have to divide this out. Now here's the bad news. Can I use synthetic division if I have a quadratic factor? I cannot. So I have to use long division, but good news, we know it's a factor. right? So even though I'm using long division, the good news is you know you're supposed to get a remainder of 0. You have several checks within this problem that you're doing it right, because you know if that long division pops up and you don't get a remainder of 0, something's wrong. Either you wrote your factor wrong, which I will tell you that's most likely the common mistake, is just setting up the problem wrong, or you divided it out wrong. All right, so let's do our synthetic division. X squared minus, or synthetic division, I said it, long division. X squared minus 6x plus 10. We are dividing it into the original polynomial, x to the 5th minus 5x to the 4th plus 2x to the 3rd plus 22x squared minus 20x. X squared times what gives me x to the 5th? X to the 3rd. Multiply it by everything on the side. X to the 5th minus 6x to the 4th minus 10x to the 3rd, and then we subtract. First terms cancel. Negative 5 minus negative 6 gives me a positive x to the 4th. 2 minus, yep. Oh, yes, it is. Thank you. Before I mess that up. 2 minus 10 gives me negative 8 x to the 3rd. Bring everything else down. Okay, do it again. X squared times what gives me x to the 4th? X squared. X squared times everything on the side gives me x to the 4th minus 6x to the 3rd plus 10x squared. Subtract. X to the 4ths cancel. Negative 8 minus negative 6, so it's like plus 6, gives me a negative 2x to the 3rd. 22 minus 10 gives me positive 12x squared, and then bring down my 20x. And then we're going to do it one more time. X squared times what gives me negative 2x to the 3rd. Negative 2x times everything on the side gives me negative 2x to the 3rd plus 12x squared minus 20x. And you'll notice those last two rows match, which is what we want to happen. Remainder 0, not a surprise. If you don't get a remainder of 0, don't go any further. Go back and check your work. All right. That quotient is going to give us our final answers. Now remember, 3 plus I and 3 minus I are already solutions, so we have 2 of the 5. Set x to the 3rd plus x squared minus 2x equal to 0, and this should be something you can just solve by factoring now. What do you notice about all 3 of those terms? Yes. What else in terms of factoring? You can factor out something they have in common, an x. That leaves me with x squared plus x minus 2. Now look at that quadratic that's left. Give me 2 numbers that multiply to negative 2 and add to 1. Multiply to negative 2 and add to 1. Negative 1, positive 2. Final answers are 0, 1, negative 2. Don't forget about 3 plus I, 3 minus I. Now this is a problem you will be doing without a calculator on the test. I promise you there will be one of these on the test. You can check these answers. If 0, 1, and negative 2 are solutions, you can plug them in and get 0. With a basic calculator, you could do that. You could also divide them out with synthetic division. 0, 1, and negative 2 should all give you a 0 remainder if they're zeros. So there are ways to check your final answers. All right, that is the end of 3-5. So, deadlines, let's talk about that. Things that are coming up. Your pre-4 Math Excel, remember, is due Sunday night. 3-5, this guy is 2nd, which is Tuesday night. Okay, so one assignment due Sunday, the next is due on Tuesday. Let me do cell phone lotto. I'm just going to do it with my calculator here. Cell phone lotto. Oh, no. That's not right. Let's try that again. 20. Who's number 20? You win a ticket. All right, the last 5-10 minutes of yours. Remember, on short periods today, we got here at 10.